And today we are going to learn about how to find domain and range of different functions and how to find x-intercept and y-intercept of a function. We already know that domain is set of the x values for which the function is defined. So in order to find domain, we have to move from left to right. And range is set of the resulting y values of a function after substituting the x value in equation of a function. So this means in order to find the range, because we're looking for the y values, we are moving bottom to top. X-intercept actually is a point on a graph where y is equal to 0 and the graph meets x-axis. And y-intercept is a point on a graph where x is 0, this time x is 0, and the graph meets the y-axis. So let's say I have the coordinate plane here, and also I have a graph here. So this point that my graph is meeting the x-axis is called x-intercept. And we know that at this point y is equal to 0. And the other point over here where my graph is meeting the y-axis is called the y-intercept. And at this point x is equal to 0. So let's try some examples. We're going to graph the function, find the domain and range, and finally find the x-intercept and y-intercept. In order to graph this function, g of x equal to x squared minus 1, the first thing is to identify the parent function, which here is y equal to x squared, quadratic function. Then we need to graph the parent function first. So this is my parent function, which is the parabola. Now, I'm going to look at my equation. It's x squared minus 1. This negative 1 is outside of my function. That means the transformation here is down 1. So to graph the new function, I'm going to move the vertex of the old one to down 1 and then graph the function. Of course, my graph is not very accurate because I'm just drawing something here. But by looking at the graph, I can just say I'm going to have 2 x-intercepts and 1 y-intercept here. But later we'll figure out what are the exact values of x and y at these 3 points. So let's find the domain first. For domain, we move from left to the right. As I'm moving from left to right, I see that everything is covered. There is no restriction. So the domain is from negative infinity to infinity. And then the range, I have to move bottom to top. As I'm moving bottom to top, there's nothing covered here. There is no part of my graph for these y values. But the first point that I'm going to see is negative 1. So that's the first point of the graph. Then it's going to continue forever to the top because my graph is going to continue. So it's from negative 1 to infinity. And the negative itself is covered because it's part of my graph. There's no hole here. So that's why I put a bracket here. Now we want to find the x-intercept. We know that when we have x-intercept, y is equal to 0. So I'm looking for an ordered pair which y is equal to 0, and we are looking for the x. So this is what I'm going to do. Y equal to x squared minus 1 is my equation. Wherever I see the y, I'm going to replace that with 0. So 0 is equal to x squared minus 1. My goal is to solve for x. So in this equation, to solve for x, I'm going to add 1 to both sides. Then these two will go away, and then from here x squared is equal to 1. Now I'm going to take the square root of both sides, so I get rid of this power of 2. Then x will be equal to positive 1 and negative 1, because we already know that square root of 1 is equal to 1 and negative 1. So this means I'm going to have two x-intercepts. One is 1 and 0, the other one is negative 1 and 0. So we found the x-intercept here. In order to find the y-intercept, we know that for y-intercept, x is equal to 0. So I'm looking for an ordered pair which has the x value as 0, and I need to solve for y. I need to find the y value. So I'm going to write my equation x squared minus 1. Then wherever I see an x, this time I'm going to replace that with 0. So y is equal to 0, 0 squared minus 1. 0 squared is 0, and 0 minus 1 is negative 1. So the answer is negative 1. So this is my y-intercept. As I told you, by looking at the graph, we could also say that we have two x-intercepts and y-intercepts. But just by looking at the graph, I cannot find the exact value of x and y because my graph is not accurate. So on your test or quiz, you need to show all your work. You need to work on your equations to find x and y intercepts. So the next equation is f of x equal to 2 absolute value of x minus 1. The parent function is y equal to absolute value of x. Transformations that I see here is x minus 1. This minus 1 is inside my function, so it's happening on x. That means this is going to move right 1. Also, we have a vertical stretch of 2 because this 2 is outside the function. So let's graph the parent function first. So the parent function looks like this. Then I'm going to graph the transformed function. Move right 1. So I'm going to start with the vertex and move it right 1. Then because this is vertical stretch, I'm going to draw this narrower and taller. Again, my graph is not accurate. I'm not finding all the exact points. I'm just drawing an estimate graph. But from here, looking at the graph, I can say that I'm going to have one x-intercept and one y-intercept. So let's work on domain and range first. Domain from left to right is covering everything. Negative infinity to infinity. There's no hole, there's no asymptote, no restriction. But for the range, as I'm moving bottom to top, there is nothing defined on my graph for the negative y values. My function or my graph actually starts from 0. So start from 0 and then goes up forever. So 0 to infinity. And 0 itself is covered, so I put bracket here. To find the x-intercept, we set the y equal to 0, and then we're going to solve for x. So my ordered pair is something and 0. The equation was y equal to 2 absolute value of x minus 1. So I'm going to replace the y with 0. So this is equal to 0. When 2 or a number times a variable is equal to 0, we know that this number is not 0, so that means this variable is going to be 0. So from here I can say absolute value of x minus 1 equal to 0. And if absolute value of something is equal to 0, that means whatever I have inside the absolute value, that is equal to 0. So from here, x is equal to 1. So we found the x-intercept. Now we're going to work on y-intercept. This time we set x equal to 0. So we are looking for an ordered pair which has x as 0, and we need to solve for the y. So we're going to use the equation, do absolute value of 2 absolute value of x minus 1. Then replace 0 for x, 0 minus 1. We know that 0 minus 1 is equal to -1, and then absolute value of -1 is equal to 1. So this is equal to 2 times 1, which is 2. So the y-intercept is found, and that's 2, like what we can see here. And of course my graph was not accurate, but I could say that I had one y-intercept and one x-intercept. Let's go to the next function. Y equal to square root of x is parent function of square root of x plus 2. On your notes you have x minus 2, so let's change this. I have a typo here, so this is x minus 2. The transformation that I see here is move left, oh I'm sorry, right, let me change this. This is move right because I have minus 2. Move right 2. The parent function of radical x looks like this. And if I want to draw the transform function, I'm going to move this, start from the 0 and 0 and move it 2 to the right, and then I can draw my graph. The domain of this function, left to right, as we see there is nothing covered here, and my graph starts from this point, which is 2, and then continues forever. So it's 2 to infinity, and 2 is covered. The range, bottom to top, again, as I move from the bottom, there is nothing, no part of my graph for the negative y values. My graph is starting from... Okay, sorry for the interruption. So for the range, we are moving bottom to top, and we said there's nothing defined for the negative y values, and then starts from the 0. So from 0 to infinity is my range, and 0 is covered, so I put bracket here. To find the x-intercept, we set the y equal to 0 and solve for x. So the ordered pair is something and 0. So 0 is equal to radical x minus 2. Because here I had the y value, so I replaced that with the 0. So if the radical is equal to 0, this means the inside of radical is also equal to 0. So x minus 2 is equal to 0, and from here we add 2 to both sides, and then x will be equal to 2. So this is my x-intercept. How about the y-intercept? Before starting to work on the y-intercept, let's just have a look at the graph. We had one point here, which was the x-intercept, but my graph is not going to meet the y-axis. So from here I can predict that I'm not going to have any y-intercept. But we have to show our work. So let's see how we can prove that. X is equal to 0. Then y is equal to radical x minus 2. So I'm going to replace 0 for x. Radical 0 minus 2. So that's equal to radical negative 2, which is not possible because we never have a negative number under radical. So this is no solution. So there is no y-intercept here. We don't have any y-intercept. Let's go to the next problem. g of x equal to x to the power of 3 plus 3. So we have the cube function here. The parent function is y equal to x to 3. We know that the graph looks like this. One side of curve goes up, the other one goes down. The domain of this function, wait a minute, first let's do the transformation. We have plus 3 after the function. This means it's outside the function. So this is moving up 3. So we're going to move our graph up 3, like here. The center will be moved up 3, and then we start graphing the function. It's going to be something like this. So by looking at the graph, I can say I'm going to have one y-intercept and one x-intercept. Let's first work on the domain. We know that the cube function has domain of negative infinity to infinity as I'm moving from left to right, even though it has been transformed, but still as I move from left to right, all the x values are covered. The same is for the range. Although this has been moved up 3, but still, since the function is continuing forever from top and the bottom, all the y values are going to cover. So negative infinity to infinity for this one as well. X-intercept, I'm going to set y equal to 0 and then look for the x value here. Y equal to x to the 3 plus 3. So I'm going to set this equal to 0 because y is equal to 0. Then subtract 3 from both sides. So from here, x to the power of 3 is equal to negative 3. Now what is x? I'm going to take the cube root of both sides. From here, x will be the cube root of negative 3. You don't have to worry about the exact decimal value of this. At this point, you can just leave it like that. So the x value is the cube root of negative 3. Because the index here is 3, we don't have to worry about having a negative under the radical. You can even use your calculator to find the exact decimal value of this. Anyway, we found the x-intercept. Now let's go for the y-intercept. This time x is equal to 0. So if I have y equal to x to 3 plus 3, I'm going to replace x with 0. 0 plus 3 is equal to 3. So y is 3. Then my y-intercept is 0 and 3. Notice that for all these x and y-intercepts, I'm putting an order. I'm writing an ordered pair because x and y-intercept are points. So I have to show them in the right form, which is an ordered pair. Make sure you always, for your answers, write an ordered pair for x and y intercepts. The next function is y equal to 1 over x plus 6. The parent function of this is 1 over x. It's the rational function. I can talk today. Okay, so 1 over x. Let's graph the function first. We know that we have the x equal to 0 and y equal to 0 as our asymptote. And then the graph looks like this. So this is my parent function. Now what has happened to my transformed function? We have x plus 6. The plus 6 is on the bottom of my fraction. This means something is happening to the x value, and it's plus 6. So we know that inside the function is a liar, so this is actually left 6. Now, in order to graph my transformed function, I have to move everything left 6. The easiest way to do that is to start with the asymptote. So I'm going to move the vertical asymptote 6 to the left. 1, 2, 3, 4, 5, 6. So it's here. This is my vertical asymptote. I'm also going to move the horizontal asymptote, but basically, because this is a horizontal line which is continuing to the left and right, basically we won't see any change because it's just the same line. Now that I have my asymptotes, I'm going to make my curves exactly like what I have here. I'm going to move it here in between asymptotes. So this is my new graph. Now what is my domain here? I'm going to move from left to right. As I move from left, everything is covered. All the x values have some point on the graph, except this point, which is actually x equal to -6. So at -6, my function is not defined because I have an asymptote here. I have to make a jump and go after -6, and then after that again my function is continuing. So I'm going to write my domain in this way: from -infinity to -6. I have to stop here, make a jump, and then continue again after this -6. So this is my domain. For range, I'm moving bottom to top, and as I'm moving, every y value has some point on the graph. So everything is defined except this one, which is y equal to 0 on this line. Again, I have to make a jump and go after that. So whenever you have an asymptote, means you have to make a jump, or basically means your function is not defined at that point. So I'm going to write my range in this way: -infinity to 0, jump 0 to infinity. So this is my domain and range. How do I find x-intercept? Set the y value 0. So y is 0, and then my equation was 1 over x plus 6. So here I need to look for the x value, solve for x. But I have a fraction here which is equal to 0. We know that in any fraction, if that fraction is equal to 0, that means the top is equal to 0. But here the top of my function, my fraction is 1. So this is not possible. So there is no solution here. That means there is no x-intercept. Even by looking at the graph, you could say that, you see, your graph is going to get close to x but never passes through the x-axis. Even from this side, approaches the x but doesn't pass through this one. So we don't have any x-intercept. But we are going to have a y-intercept, because if I continue this line, it's going to meet somewhere like here. It's going to be a very small value. So I will have a y-intercept. So let's find that y-intercept. Set x equal to 0, and we are looking for an ordered pair, which x is 0. So y is equal to 1 over x plus 6. I replace x with 0, so it's 0 plus 6, which is 1 over 6. So the y value of y-intercept is 1 over 6. This is my y-intercept. Now let's work on the next function. Again here, my parent function is 1 over x. But what transformation do I have here this time? As you see, this -5 is outside of your function. It's not in the bottom of your fraction. It's outside. So it means I'm moving down 5. Again, the first thing is to graph the parent function, which is this. And then down 5, I'm going to move that down 5. As we said, the first thing, the best way actually to graph a transform rational function is to start with the asymptote. So I'm going to move the asymptotes down 5. If I move the horizontal asymptote down 5, 1, 2, 3, 4, 5, it's going to be here. And the vertical asymptote, as I move it down, basically I'm not going to see any change because it's just continuing down. So the graph is going to be here and here. I'm going to erase this part to make space for my domain. Now for domain, I'm moving from left to right. As I'm moving from left to right, I see that my graph is covering all the x values except here, which x is equal to 0. So, and then after that again it's going to continue. So my domain is from -infinity to 0, jump 0 to infinity. So always if you have an asymptote in your rational function, you're just simply going to make a jump on that asymptote. For the range, I'm moving bottom to top, and where I need to stop is here, which is y equal to -5. I have to make a jump here because I have an asymptote here. So negative infinity to -5, jump -5 to infinity. Now let's find the x and y intercept. By looking at the equation, I can say that if I continue my function this way, it's going to cross the x-axis here. So I'm going to have an x-intercept. But how about the y-intercept? My function, my graph is getting close to y-axis but doesn't pass. Even from this side, gets close but doesn't pass. So I know that I'm not going to have a y-intercept. So let's see how we can prove it from the equation. X-intercept, I'm going to set y equal to 0. And then y equal to 1 over x minus 5. Then 0 equal to 1 over 1 over x. Let me fix this. 1 over x minus 5. So the first thing is to add 5 to both sides. So this will go away, and then this was a fraction. Then 5 is equal to 1 over x. Now how can I solve for x here? The simplest way is to do the cross multiple. So I'm going to put a bottom for 5, which is 1, because 5 over 1 is 1, and then do the cross multiple like this. So from here I can say that x is equal to 1 times 1, which is 1 over 5. So this is the x-intercept. 1 over 5 is my x-intercept. Now let's find the y-intercept. We're going to put x equal to 0 and look for the y value. So y is equal to 1 over x minus 5. Wherever I see an x, I'm going to replace that with 0. 1 over 0 minus 5. But is this possible? No. 1 over 0 is actually undefined. That means we don't have any y-intercept because we couldn't solve this y. So there is no y-intercept. Okay, this was our lesson for today. I have also written the answers for exit tickets, so you can check these answers. And that was it for today. Have a great day.